in a context where you need to decarbonize the economy. When we're talking about chemical industry, we need to replace most of the oil-based raw materials for bio-based materials. So who better to transform bio-based molecules than the enzymes? So the agents that transform these bio-based molecules in nature are now going to transform them in industry. In RadicalZ, we identified a limitation in bringing enzymes as a solution. You need to find them and adapt them to the industrial process fast enough. We proposed in this project a platform of enabling technologies will allow us to do this cheaper and in a time frame that is compatible with the development of industrial products.
So when we do enzyme engineering, we create libraries of millions of mutants. And if we do this, characterize them manually, 1 million experiments, which is of course impossible to do. And with microfluidics, we can find the needle in the haystack without major efforts. So microfluidics technology means that you have tiny droplets, and each droplet contains a gene encoding for the enzyme of interest. And then we can analyze 1 million clones within a few hours, if we are lucky, within a day. And then we have a much better enzyme for a given application.
If we build a good database with microfluidics, we can feed that into AI. Then AI can help to very fast and very specifically figure out novel enzymes and novel sequences that we can then test into that. And this will just shorten development times for us.
We really had to innovate our way through some very specific AI challenges to get the stuff to work. We see some great results. We have great collaborations where we really enabled the lab work to kind of make bigger jumps.
On the application side of the enzymes, the enzyme can be flushed away in the waste, and this can reduce the production efficiency. So to solve this problem, we propose to use carrier. It's basically like a little vesicle, little capsules that we can encapsulate the enzymes inside and can ensure the enzyme activity during the entire fabrication process.
Many products in the market are produced synthetically with chemicals. And that's why we try to develop a method for the production of a natural aroma that can be used in cosmetics. We found that it is possible to produce this compound from precursor in plants. So the end product from our development, we put on the market a natural product, and that's safe for our body.
Nutraceuticals are molecules that are either added to food or are present in food that have a health benefit to the consumer, to the end consumer. They can be synthesized or generated by chemical means using chemical processes, which is of course not very environmentally friendly. And that's why if you use enzymes for this, it's much more environmentally friendly. In this project, we want to use enzymes that make prebiotic molecules, nutraceuticals, directly in the consumer product. For example, in milk, in yogurt, or in cheese.
We're addressing laundry in a way where we're looking at a lot of microplastic waste, which goes into the wastewater from laundry. And microplastics cause a lot of harm to the environment and also can get into even cells in our body. So we're approaching the project by looking at a thermostable enzyme to evolve for optimal activity of breakdown products. Plastic can actually take the microplastic content out before it goes into the waste source.
Enzymes are really key catalysts and key actors today of the circular bioeconomy because, they are natural catalysts, they can be biodegradable, and they can have a huge catalytic power. And if it's not enough efficient for a process to be profitable, we will further modify it. And we have all those tools.
So I think enzymes in general and biocatalysis will certainly have an important role in the future and in the society. I think that the area of biotechnology, especially considering the green impact, which of course need to be quantified.
Being industrially attractive, economically efficient and green at the same time can be possible. In RadicalZ we have set some kind of culture in this sense, also with some tools, and it's also kind of message that I think has gone through in this project.
In terms of communication from the RadicalZ project, we have managed to create a broad community online, but what is beautiful about this project is that we've gone beyond that with the different dissemination materials that we have created for children and teenagers, for example.
The project has been quite a success. Most of the tools that we have developed, the machine learning tools, the microfluidic assays, the mathematical models, they work. They're useful, they're effective. I think that's the biggest compliment someone can pay to someone's work.